Welcome to This Explainer. I am absolutely thrilled to have you here today because, look, we're tackling one of the most notoriously tricky topics in the entire Cambridge AS and A-level mathematics syllabus. We're talking Subject Code 9709, specifically Newton's laws of motion on inclined planes. If you have ever stared at a past paper question involving blocks sliding down ramps, pulleys, and friction and just felt your mind go completely blank, you are absolutely not alone. So many students lose easy marks on this exact topic. But today, that changes. I'm going to reveal the insider's playbook. We're going to look directly at what senior examiners and subject specialists are actually demanding from top-tier candidates. By the end of this, you're going to have a strategic framework that doesn't just maximize your marks, it practically bulletproofs your exam performance. Okay, let's dive into this. Why do students find applying these concepts to unfamiliar contexts so incredibly difficult? You know the feeling. You sit in class, you nod along as your teacher explains F equals ma, you totally get the gravity pulls down and the normal reaction pushes up. The physics makes perfect sense in isolation. But then, you get into the exam hall, the question presents this wild system of connected particles on a rough inclined plane with an external force acting at some random 30-degree angle to the horizontal. Suddenly, panic sets in. You rush the question, you miss the command word requirements, or you just overload your page with raw math facts but absolutely no structured analysis. You end up with a flawed answer covered in red ink, even though you fundamentally understood the physics. So why does this happen? Well, here is the absolute truth of the matter. It's not the math, it is the methodology. The reason you're losing easy marks isn't because you forgot how to resolve a force using sine or cosine. It's because Cambridge examiners aren't just testing your ability to punch numbers into a calculator. They're testing your strategic process. They're looking for a highly specific, methodological approach to problem solving. If you rely on blind calculation without a structured method, you're walking on thin ice. To truly master Newton's laws on inclined planes, we have to shift our focus entirely away from just getting the right numerical answer and hyper-focus on how we build the argument to get there. Here's our cognitive roadmap for today's explainer. First, we'll break down the inclined plane challenge. Second, mastering core principles. Third, we'll deploy the method mark strategy. And finally, top examiner warnings. All right, let's kick things off with Section 1, the inclined plane challenge, and decode what examiners really want from you. To beat this challenge, we have to understand the theoretical architecture of the 9709 syllabus. The examiners are designing questions that rest on precise definitions and causal relationships. Think about it. If force X increases, what happens to acceleration Y? If the plane suddenly becomes rougher, how does that impact the tension in the string? You cannot treat these variables as isolated numbers. You have to understand the dynamic system as a whole. Let's pull back the curtain and look at this official quote straight from the Cambridge Principal Examiner reports. It literally says, candidates referencing cross-topic connections achieve significantly higher marks. Think about what that actually means. Isolated memorization just won't cut it. Examiners want to see you integrate Newton's laws with other syllabus areas. Are you connecting the acceleration you just found using F equals ma to your kinematics equations, your SUVAT equations, to find the time it takes the particle to reach the bottom? Are you connecting the forces to the work-energy principle? The top 1% of students don't view math topics as separate boxes. They see them as an interconnected web. And that brings us perfectly to our second section, mastering core principles and building that connected understanding. The syllabus explicitly emphasizes that top-performing students exhibit a conceptual understanding that's effortlessly transferable to unfamiliar contexts. When Cambridge throws a weird novel scenario at you, maybe a particle moving up a plane that suddenly changes roughness halfway through, they are testing to see if your core principles are solid enough to adapt. Notice the stark contrast between these two cognitive domains here. On the left, we have basic knowledge. This is simply stating F equals ma or defining the coefficient of friction. It's necessary, sure, but it's low level. Now, on the right, we have higher order mastery. The assessment objectives here target application and analysis. It means taking that basic knowledge and applying it to evaluate alternatives, like will the block tip over or will it slide? What's the justified recommendation for the maximum mass you can add before equilibrium is totally broken? Examiners are actively looking for this higher order mastery. And really quickly, before we look at the exact strategy to secure these marks, remember to subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. Hit that subscribe button so you never miss these essential breakdowns. All right, so the crucial point is we need to shift from theory to the strict procedural framework that will actually get you the grade. Welcome to Section 3, the method mark strategy. Securing your process marks is hands down the single most important skill you can develop for the 9709 paper. The method mark strategy is essentially a defensive exam tactic. Let's say you're under intense time pressure. You've drawn the diagram, you've set up your equations, but somewhere in the heat of the moment, your calculator spits out a negative mass. You know it's wrong, but you only have 30 seconds left on the clock. What do? Well, if you've been using the method mark strategy, you don't panic, because method marks are awarded for demonstrating the correct systematic process and showing clear working, even if that final numerical answer is dead wrong. This strategy is a vital lifeline. It can literally save your grade when calculations fail. To guarantee you secure those marks, you must follow this standardized, stress-tested sequence. Step 1. Identify key elements. What's the mass? What is the angle of the incline? Is the surface smooth or rough? Step 2. Apply relevant principles. This means drawing your free body diagram and resolving your forces perpendicular and parallel to the plane. Step 3. Execute analysis with clear working. Write out your equations of motion so the examiner can actually read them. Step 4. Verify results. Do a quick mental check. Does the direction of acceleration actually match the resultant force? And Step 5. Present in appropriate format. Following this exact sequence guarantees the examiner can follow your logic, scoring you every possible method mark along the way. Let's move on and see how this builds into higher-order questions. Sometimes you're asked to evaluate different scenarios, say, comparing the motion of a particle on a smooth plane versus a rough plane. The source material outlines that comparative analysis requires a really highly structured approach. You must identify similarities and differences. You have to use comparative connectives, which in mathematics means using clear inequalities or ratios to show how one value relates to another. You absolutely must support each comparison with evidence, meaning you show your calculated values. And finally, draw conclusions about their relative importance. This specific analytical breakdown is exactly what pushes an answer from a B grade straight up to an A-star grade. Now we need to shift gears into pure defense mode. Section 4, Top Examiner Warnings, and how to defend your grade. Listen closely, because I am about to share with you the absolute most common pitfalls pulled directly from the Cambridge Principal Examiner reports. These are completely avoidable errors that are probably staring you right in the face. First up, forgetting to include the proper format for inclined plane problems. This means not stating which direction you are actually resolving forces, or failing to use correct terminology. Second, failing to check presentation and clear annotation. If your examiner cannot read your free body diagram, or if your normal reaction force isn't clearly labeled at exactly 90 degrees to the surface, you lose marks. It's that simple. Third, providing answers that are not specific to the given context. Please don't just regurgitate a generic formula. If the question gives you a mass of 5 kilograms and an angle of alpha, your working must explicitly use 5g sine alpha, not just mg sine theta. It is incredibly easy to fix these presentation issues, but if you ignore them, you are just throwing marks out the window. To help you avoid those exact mistakes during the intense stress of the exam, I want to share a quick, honestly pretty surprising tip. Use a visual story method to encode your concepts. When you look at an inclined plane, don't just see a bunch of lines and letters. See a story. The block is the protagonist. Gravity is the constant antagonist pulling them down. The normal reaction is the solid ground supporting them, and friction is the stubborn resistor fighting against their movement. By linking abstract mathematical theory to a visual layout, you map the strict conventions right into your brain. When you're under pressure, this visual story helps you rapidly recall exactly where every single vector needs to be drawn and annotated. So, I want to leave you with this final provocative question. Are you going to let another totally avoidable presentation mistake cost you your grade, or are you ready to deploy the method mark strategy? Remember, it is not just about the final numerical answer. It is about showing every single step of your working, connecting your topics, and strictly following the procedural framework. Get out those past papers, practice the strategy, and master the methodology. And as a final reminder, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Drop a comment below with your target grade, and let's ace this together.